show that any positive odd integer is of the form 6q plus 1 or 6q plus 3 or 6q plus 5 where q is some integer. Solution. Let a be any positive integer and b is equal to 6. 6 is the coefficient of q. We know Euclid's division algorithm. Is a is equal to bq plus r, where value of r is 0 less than or equal to r less than b. The value of b is 6. Therefore, values of r is equal to 0, 1, 2, 3, 4, 5. If r is equal to 0, then a is equal to, what is the value of b? 6. Q plus value of r is 0. Therefore, a is equal to 6q. If r is equal to 1, then a is equal to 6q plus 1. This is even. This is odd. The multiples of 6 are 6, 12, 18, 24, 30, so on. If we multiply 6 with any number, then add 1, we get odd number. If r is equal to 2, then a is equal to 6q plus 2. If we multiply 6 with any number, then we add 2, we get even. If r is equal to 3, then a is equal to 6q plus 3. This is odd. If r is equal to 4, then a is equal to 6q plus 4. This is even. If r is equal to 5, then a is equal to 6q plus 5. This is odd. Therefore, if r is equal to 1, r is equal to 3 and r is equal to 5, then we get odd numbers. That is, any positive odd integer is of the form 6q plus 1, 6q plus 3, 6q plus 5. Third question. An army contingent of 16 members is to march behind an army band of 32 members. In a parade, the two groups are to march in the same number of columns. What is the maximum number of columns in which they can march? There is a group of 16 members and 32 members in a parade. So we have to find HCF of 616 and 32. We know Euclid's division algorithm. A is equal to bq plus r. 616 is bigger number, then it is dividend. 32 is divisor. 32 ones are 32. 11, 5, 2, 9, 6. 32 nines are 288. 16, 8, 8. A is equal to 616, B is equal to 32 into 19 plus R is 8. Again, 8 is divisor, 32 is dividend. 8 4s are 32. 32 is equal to 8 into 4 plus 0. Therefore, HCF of 616 and 32 is 616 and 32 is 8. Therefore, the maximum number of columns in which they can march is 8. Use Euclid's division lemma to show that the square of any positive integer is either of the form 3m or 3m plus 1 for some integer m. Let a be any positive integer and b is equal to 3. 3 is the coefficient of m. According to Euclid's division algorithm, a is equal to bq plus r. The value of r lies in between 0 and b. Therefore r is equal to, the value of d is 3 less than, so the r values are less than 3, 0, 1, 2. If r is equal to 0, then a is equal to 3q plus 0, that is 3q. In the question he is asking square of any positive integer, so we have to square on both sides. A square is equal to 3q whole square, 9q square, that is equal to 3 into 3q square. Let us assume k1 is equal to 3q square. Therefore the value of a square is 3k1. If r is equal to 1, then a is equal to 3q plus 1. Squaring on both sides, a square is equal to 3q plus 1 whole square. It is of the form a plus b whole square. Formula is a square plus 2ab plus b square. A square is equal to 9q square plus 2 3 are 6, 6q plus 1, that is equal to 3 into 3q square plus 2q plus 1. Assume k2 is equal to 3q square plus 2q. Therefore value of a square is 3k2 plus 1. If r is equal to 2, then a is equal to 3q plus 2. Squaring on both sides, a square is equal to 3q plus 2 whole square. A plus b whole square formula, 3 3s are 9, 9q square plus 3 2s are 6, 6 2s are 12, 12q plus 4. 3 is common, 3, 3q square plus 4q plus 4. This 4 can be written as 3 plus 1, that is equal to 3 into 3q square plus 4q plus 3 plus 1. 3 into 3q square plus 4q plus 3 plus 1 plus 1. Assume 3q square plus 4q plus 1 is equal to k3, that is equal to 3k3 plus 1. Let m be any positive integer. Therefore the square of any number is either of the form 3m or 3m plus 1.